Before there were automated ways to provide IP addressing for the devices on your network, it used to be a manual process to configure every single device. You had to go to a computer, configure its IP address, configure its subnet mask, define its default gateway, and any other parameters that you had to have configured in that device to be able to communicate out on your network using TCP/IP. So in October of 1993, we came up with an automated way to do this called the Bootstrap protocol, or BootP. We called it the Bootstrap protocol because when your computer is starting up, we call that the computer starting up by its bootstraps. And because of that, anytime your computer would bootstrap itself, it would then run this particular protocol to automatically get some addressing inside of the device. But BootP still had some limitations. It was not able to configure everything. We still manually had to go in and configure different settings inside of our devices, and BootP had no mechanism in place to understand when a device might leave the network and then have that IP address available for others to use. Because of that, we upgraded BootP into something called DHCP, or Dynamic Host Configuration Protocol. DHCP was created in 1997 as a successor to BootP, and we've continued to update it throughout the years. There's a four-step process that occurs when you turn on a computer and have it obtain these IP addresses automatically. Let's look at what each one of those steps might be. On this network, I've created a picture that is of a relatively large network. It has a client workstation, there's a switch in the middle, there's a DHCP server right on our local network, and then I also have a router that connects out to other parts of the network where there might be another DHCP server. This is something you commonly see in very large environments where you may need redundancy in your DHCP server, so this is a common way to do that. The first thing that happens when a device starts up is it sends a broadcast out to UDP port 67, and it's of course a broadcast, so it's going out to everything on the network. So as that packet goes out, it's going to be seen by every device on the network. That discover process is seen by the DHCP servers, which then go to step 2 and send back a response or a DHCP offer to that broadcast. And it's sending, again, a broadcast out to whatever device happened to send that. It can't send a directed frame or a unicast because obviously our client workstation doesn't yet have an IP address. Now in this example, I'm showing the broadcast going directly to the client workstation, but of course you can imagine that because it's a broadcast, it's going out to every other device on the network. Once this client workstation now has an offer that has been made by those DHCP servers that says, here's an IP address and a subnet mask you could use, here's some options available for you, the workstation considers those options and then decides it would like to get a DHCP request. So again, it's sending out a broadcast out to a specific DHCP server saying, I got your request and yours is the one that I would like to use. So we send it out to one specific DHCP server. Obviously, we're not going to ask and get multiple IP addresses. We only need one. So our end station is going to choose which DHCP server it wants to use and send the broadcast out to that specific identifier for that DHCP server. And the final step is for an acknowledgement, a DHCP ACK. The DHCP server sends this again as a broadcast because obviously the end station does not yet have an acknowledgement that it owns that IP address. So our DHCP server sends out that broadcast that is ultimately seen, of course, by everybody on the network, but because it is directed just to this client workstation, that's the only device that will understand that, yes, that's intended just for me. And now I've confirmed my IP address, my subnet mask, my default gateway, and any of the other settings that we have inside of our DHCP server. This is the process that happens every time we turn on a computer and we connect it to the network and it gets its automated IP addressing. There's a DHCP discover, there's the offer from the DHCP server, there's the client then saying that I would like to request then the offer that is made to me, and finally the acknowledgement from the DHCP server that it has received that request and has locked in that IP address just for that device.